when a programmer declares any array and when JVM execute that line of code. So for that, if we take one array, say integer type of array, so int the array name ARR equals floor brackets, then some numbers here, say 25, 67, 72, some 45, 54, some numbers have taken. So when JVM execute this particular line of code, and we are writing inside a main method. So when JVM execute this line of code, what will happen? That is, arrays will be stored in the heap segment of the memory. Therefore, in RAM, we discussed the 5 memory segments, but I am taking only required segments for this array, not all the 5 segments. One is the heap. Because when JVM execute this line of code, first right hand side part will be executed and arrays are objects. So at this point of time, remember, then there is a next way of declaring a array with a different syntax. That is where I can convince you why it is an object. Okay. So for that, whenever JVM execute this right hand side of code, the 5 cells will be created. And then in each cell, JVM will store the elements in the given order only 25, 67, 72, 45, 54. Then for this, JVM will give the indexing numbers from 0, 1, 2, 3, 4. This 4 is a last index. This 4 is last index. And then for every array, there will be a property called length property. So therefore, so for this one hexadecimal address will be generated. That is a 0x format. Then some number I'm taking randomly. So this is the address of this array object. Yeah. So then followed by, after this right hand side execution, this is what will happen. Then JVM comes to left hand side. So here is a ARR, which is a variable. Can you please tell me it is what type of variable? Is it local, static, or instance? Any
Instance variable, sir.
okay, why it is instance?
Because
So a
I don't
variable
know.
which is present inside a method, a variable which is present inside a method, which is main method, it is nothing but a local variable. So this ARR is a local variable. That's why it is stored in stack segment of memory. Yeah. So then, so here ARR. So since it is not referring to a value directly, it is referred by some object. It's referring to some object, right? That's why this ARR will not have any value, but it will have the address of the same array object called here 0x100, then here also 0x100, and its type also will be stored and that much internally not required. So it is int array type. Yeah. Then this object is pointed by this variable called ARR because it is having address. This address will be mapped to this object. That's how it is. It will be stored in different segments of memory. Then, when programmer is trying to access the elements of this array in reverse order, just as for example, say reverse order. Then for that, what is that we have to write? So in a normal approach, from last index, first we have to print fourth element, then third element, second, first 0. So for that, we will be writing some inside a print statement ARR of 4, then ARR of 3, then ARR array name 2, then array name 1, then array name 0. So these are the indexes which we have to access if you want to print in a reverse order. Then how JVM will execute this one? Even though if you are writing for a for loop by using for loop also, how JVM execute that for loop? So first, to generate a generic logic, to write a generic logic to print the array elements in reverse order. So what is the generic logic, please? For int some variable I. So here can we write for last index to start with? Yes, we can write it, but it will
No, sir.
become hard coding. It will not become a generic logic. It means which will not work for different sizes of array. I mean array with some more elements or some less elements than this. It will not work. Then what is the generic way? Use the length property array dot length. Length will give total number of elements, but last index is one less than that. That's why. So this is the generic logic which we can use to print the reverse order of the array elements. Then semicolon, and I should be greater than or equal to 0. This already we know, y greater than and all. Then I minus minus we can write here. Then inside this for loop body, system.out.println, print I. Am I correct? Printing I, is it correct or not?
Wrong, sir.
No, because if you print I, what's output we are going to get? Only the index numbers. But we want indexes
For
or we want
the
array elements of with index.
array elements.
So ARR, then square brackets I. This is the common mistake which will make. Syntactically, we will not get any error, but output wise, we don't get the expected output also. Then opening of main, closing of the main. So when JVM try to access the first element of the array after the execution of first line, when JVM comes to this for loop, first I value will be loaded as 4 according to this generic logic. Then condition is true, therefore JVM will enter into the body. And here, what we are trying to access? We are trying to access the ARR with some index number called 4. So therefore, JVM has to access the data from memory. So first, JVM goes to the stack memory because JVM knows it's a local variable. ARR is a local variable, JVM knows. Then here, ARR, when JVM trying to get or fetch this value, it is not a value, it is some address. Therefore, based on this address, JVM goes to that location. And this location is having some indexes. So from 0, then go to 1, then JVM goes to second, then third, then fourth, then picks this value 54, and it gives output as first value 54. So again, the loop process will happen. Decrementation, condition check, again true. Then the same process. First JVM goes to this stack, then pointing the address, then goes to this location. Then here goes to third location and prints the output in the next line called as 45. Then the same story will happen till all the numbers to be fetched. Then the condition becomes false. Loop will be terminated. Yeah. So like yesterday I have discussed one property that JVM, sorry, arrays are objects and objects will be stored in heap segment of memory. Then how JVM will access the heap object, the object which is present in heap from a local variable is this is what the pointing process. Yeah. If really you want to observe, we know the debugging technique. You can put the breakpoints and debug this program. You understand what I'm discussing about. Okay. From variable section, you can notice what is the ARR value. Is it a value or is it address? You'll find something called ID. It's identification or the address. Am I clear, guys?
Clear, sir.
Yeah.
Sir, what about like if single digit is there, sir, for that single
Like,
digit, is it possible to come from reverse, sir?
what do you mean by single digit? I didn't understand.
Like 1122. For that, that number, we can use this method, sir.
So first, what is
Based
your
on memory allocation.
what's your array?
Array is like int I
Okay.
square brackets I is equal to 1122.
This is the number. Correct?
Yes, sir. Only this number, sir.
Yeah.
Yes, sir. For this, how to do reverse? For this, can we do like memory allocation and all?
So it
For
is not
this
we will
number
be doing it. JVM will do that internally. Yes, it's the same story again. Again, if this is written inside a main method for execution, when JVM execute this line of code, the same thing will happen. First, in the heap memory, JVM will do it. Okay, we will not do it. So in a heap memory, JVM will create one object to store one element only because this array is having one element. So then followed by it generates one address. So again, some sample address I'm taking hexadecimal format. The next left-hand side, the stack, where I is a variable which is having a address of the array and it will be pointing to that location. So when you try to access, first JVM comes to stack, then with address goes to heap and get this value, which is presented 0th index number position. That is process.
Can we reverse this number, sir?
We cannot reverse. Am I reversing any number or we are reversing only the elements of the arrays? 54
Only
is 54 only.
the
I'm not saying it's
elements.
45.
Okay, sir.
Yeah.
Like in previous and all, you were saying like we were doing like reversing the number. We cannot do this one. That's what my doubt was.
No. This is just printing the reverse order.
Okay,
Yeah, there is a difference.
okay, sir. Got it.
Yeah. The next. Any other questions, please? Yeah. So again, based on some numeric array, I mean integer array, there are some more things for us to understand. If there is again some integer array, say x for example, inside this there are some elements. So for our discussion purpose, I'll take some 10 elements. The 10 elements are there. Then yesterday we had some questions. Then what are the next possible questions that we can expect from this? So yesterday we discussed about only printing even, printing odd, printing sum of even, printing sum of odd, sum of all our elements, print same order, print reverse order. These things we discussed, right? Then can we print prime numbers of array? Print prime numbers of array. Possible question or not?
Possible, sir.
And then print sum of prime numbers of array. Print sum of prime numbers of array. Yeah. Next, print the difference between sum of even numbers and sum of odd numbers. Sum of even and sum of odd numbers of array. Yeah. Next, print Fibonacci numbers of array if it is there. If the array element is a Fibonacci number, print it. Print Fibonacci numbers present in array. Yeah. So then the next questions that we can expect is any other numbers? Prime numbers, Fibonacci numbers. Yeah. So these are some questions. So all these are even yesterday's part and this part. Do they based on any specific indexing? or we have to consider every element of the array? So for all these questions, we have to consider every element of array and we have to check each number is prime number or not. Each element is prime number or not. And for this also we have to check every element of the array. And if it is a prime number or not, then we have to find the sum. Then here also, so we have to check each and every element, then which is even, which is odd, then find even sum, find odd sum, then print the difference. Then print Fibonacci number. Is every number of array is a Fibonacci number or not? We have to check. Yeah, so these are some basic level questions only where we already know the logic, we have to implement on arrays, that's all. But here, there are some other types of questions. Again, I consider the same integer array only. So here, let me write some questions. You'll understand what is the difference between the previous types and these types. Write a Java program to print even numbers present at even index of integer array. Similarly, print even numbers of array present at odd index position. The next, odd numbers of array present at even index. The next, odd numbers of array present at odd index position. So these are the then next questions. Then similarly, once we know this, then print sum of even numbers present at even index. Similarly, print sum of even numbers present at odd index. Similarly, print sum of odd numbers present at even index, odd numbers present at odd index, like this. What's the difference between the previous questions and these questions? Are they same or different?
Difference. That is only printing. This is sum of numbers.
So here, so any of these questions, like yesterday I have listed some questions of some 4 or 5. Then here also I have listed some questions. These are not index based. So therefore, simply we run the for loop for entire array. And inside the loop, we perform based on every array element. But here, these are nothing but not, of course, entire array, but not every element of the array. There is a extra condition we have to add. That is, array element is even or odd we have to check, and also index position also even or odd we have to check. Even or not we have to check. Similarly, element should be even, index should be odd. Then only consider them and print it. And similarly here also odd element or even index, odd element, odd index, like that. So it is a different from the previous questions. For example, to make you understand, if I take one question to explain what is the difference, then the remaining you can do it. So if I choose the option of, say, all these again based on integer array, that's my disclaimer. Print sum of even numbers of an integer array. Then similarly, so here I'll take print sum of even numbers present at, say, odd index of an array. Are these two questions are same or different? They are different, right?
Right.
So to understand this, first let us consider the same array and we'll see what is the difference. So here I'll take one integer array. Array name is, I'll name it as, say, A equals, inside this flower brackets, let me take some numbers, say 11, 12, 14, 13, 15, 16, some numbers, then next 18, 20. 19. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, whatever it is. The same array also I'll take here. Int A equals 11, 12, 14, then 13, 15, 16, 18, 19. This is the array. So before we write the code, so first let us understand what is our expected output. Expected output is, so first, in first scenario, what we have to consider? All even numbers of the array. So 12 is even number, then 14 is even number, 16 is even number, 18 is also even number, right? Then we have to add these and print the sum. How much is that? The expected output for this program has to be how much? Anybody? Mathematicians. 60 is the output. Because 16 plus 14, 30, 18 plus 12, 30, 30 plus 30, 60. Correct now? Yeah. Are you there?
Yes, sir. 60.
Yes, sir.
So when it comes to second scenario, first let me write the indexing. 0, 1, 2, 3, 4, 5, 6, 7 are the index numbers of the array elements. Then here what the requirement? The requirement is, so first thing, sum of even numbers of the array present at odd index. First number has to be even. So which is even? 12 is even. 14 is even. Similarly, 16 is even. 18 is even. Then should we consider them to find the sum? No, because there is an extra condition is added in this. What is the extra condition? It is clearly asked to consider the elements which are present at which index? Odd index only. The element has to be even. Therefore, the remaining are ruled out. Then the index position of that should be odd as well. Is 1 is odd?
Yes, yes, sir.
Yes. So we have to consider this element because even number, odd index position, both are matching. Then this is even number, but is the index is odd number?
No.
No, out of this, then don't consider this. It's not required. We should not consider, I mean. Then similarly, element is even, index is odd. So we have to consider 16 also. Then element is even, but index position is not odd. This is not odd. So therefore,
That's
don't
not
consider that
possible.
also. So here what we have to consider? Only 12 and only 16 has to be the
Mm-hmm.
consideration.
28.
So we will be getting, or we have to get the output as 28. So that's how we have to write the logic separately. What I mean to say, the first one is purely based on only elements, but second one is based on elements and also indexes combination. That is the difference. Am I clear, guys?
Clear, sir.
Yeah. So then, how do we write a code for first one? Print sum of even numbers. Again, if these elements are not there also, still we have to get, still we have to write the logic which should work for every type of integer array. Okay, that's called as a generic logic. So since we have to find sum, so we need some reference variable. Let us take sum only whose value to be initialized to 0. Then to consider each and every element of the array, so take for loop. For loop int I equals, by default every array element starts from 0th index position. The next I should be less than or equals, what's the generic logic?
7.
Generic logic,
Length minus 1.
array
Length
name,
minus 1.
only length means wrong. Array name dot length property, then -1. If you write only length, then it is wrong. It's which length? A's length.
Length.
So then followed by, it's a increment order. So plus by 1 or plus plus. Then inside this, what we supposed to write? We have to access the array elements, correct? But should we consider every element or only even numbers?
D even.
Only even numbers. Then first, how to get the array element? Array name A with index position I. So this is nothing but array element, correct or not?
Sir.
Then how to check this as even number? Modulo 2 double equals 0. Then if this condition satisfies, that's why I'm using a condition here. If this condition satisfies, then only find the sum. How to find the sum? That array element has to be added to the reference variable called sum. And since the next time also we have to add to the same reference variable, that's why assign back to sum, end with semicolon. So this is the for loop, and inside it, if this is the condition to check even number. Then next, outside this, system.out.println, print the variable sum. That's all. Clear? So if you write this inside a method, it can be main method or individual method approach, and then method calling process we can apply for this. We'll see one example through Eclipse also. I'll execute this. If this is clear, guys, how to write it?
Sir.
Sir, how would you consider I is to I only we are giving as index? How would you consider, sir?
Sorry?
How would the JVM will consider I is only like elements of array, sir?
How to access array elements?
No, sir. How JVM will consider I is only like the array elements?
I is not array element. I is an index position, which we are using for
yes,
array
sir.
A.
How? No, sir. But we are not saying I is like index. We didn't mention anything. But if you take instead of I, if you take X, Y, still how it will consider as a index? This one, sir.
Yeah, we can't take X and Y without defining. That's the first point. Then second thing is,
yes, sir.
So first we discussed about how to access array elements with one example in yesterday's class. When I'm listing out the properties, I have listed a property that it is possible to access the array elements by using the array name with index. Correct or not? This is what I'm talking about. Correct, no?
Yes, sir.
What's the process? Array name, square brackets. Inside we have to give index number in integer format.
Okay, yes, sir. Square brackets will say that's
Accessing the array
index value.
elements. Yeah.
Right, sir.
So here also the same thing, right? Square brackets in terms of directly giving some 0, 1, 2, we are generating a loop and we are giving that I value.
Okay, sir. Got it. Yes.
So you said you have executed all the programs, right?
Yes, sir. Like suddenly I got it out, sir.
Yeah. So this is yesterday's given question. Yeah, of course, it's fine. So we access array elements by using array name, which is A in this scenario. Then square brackets, we will be using, that's a part of syntax. Then inside the square brackets, you have to give the index number. We can give a direct number or we can give a variable which is having a number in terms of integer formats. Yeah?
Yes.
Yeah. So I don't think so. I need to explain this. Finding sum of all numbers from 1 to 100 we did. The same thing we are implementing for array elements. How this logic is working, we know it already. Yeah. So
Yes,
shall
sir.
I move to the right hand side question?
Yes, sir.
Yeah.
Yes, sir.
So here, print the sum of even numbers of array present at odd index. So it is the same program or we need to add some more conditions?
Add one more condition.
Yeah, add one more condition. So first I'll take int sum equal to 0 as a reference value. Then same for loop because we have to consider every element of the array. So int I equals 0. And if you observe, what is the index? Odd index. Okay, I'll tell you both the ways. Then here, I should be less than or equals. To make it as a generic, a dot length, array name dot length property -1. Then incrementation by +1 I ++. Inside this for loop, what is that we have to write it?
Condition.
First condition. What is the first condition? Check the element is even or not. How to check it? Array name, index position with I variable,
Modulo.
we access the element. Then to check it's even or not, modulo 2 double equals 0. So first part is our number is even or not, we are checking. Then at the same time, what is the next condition? The index number has to be odd. So index is present in which variable?
I.
I variable. Then to check it as even or odd, I mod 2 not equal 0 is the condition. Correct or not?
Yes, sir.
Then one has to be satisfied or both has to be satisfied for this requirement.
Both. That's
Both,
why and
ampersand, ampersand.
So we use a logical
Ampersand.
logically
and
made.
operator or logical ampersand, then followed by inside this if this condition satisfies, then only add that array element. By chance we'll write I, syntactically no problem, but we get the incorrect output. Then add that to the reference variable called sum and assign back to sum
Sum.
for multiple iterations. Then see here we can print it the sum variable. Understood? Understood?
Yes, sir.
So here the next improvisation. The improvisation is instead of writing this entire thing, we can make sure that the loop will work for less number of iterations by understanding what index numbers we want to consider. Only odd, right?
Odd.
Then can we generate directly
Yes.
odd indexes only? Int I equals to odd index of any array starts from 1. Correct or not?
1.
So up
Yes.
to last index of the array, then this is no change as the generic logic of array name dot length property minus 1. Then 1 after 3 we want. Then 3 after 5 you want. Then what's your
I-
incrementation?
I is equal to I plus 2.
That's it. So this will make the number of iterations less compared to the previous one. This is preferable. Now here we made sure that indexes are odd only. Then do we need to have this condition?
No, sir.
No, that's it. So if you are writing this above 1, then this condition is not required at all. It's optional. Still, if we write it also, unnecessary JVM's time will be wasted. I mean, our program output will be delayed. Okay. Just to compare, I have written this same approach, but we can improvise this way also. And this condition is not required if we make sure indexes are odd already. Clear, guys?
Clear, sir.
Yeah. So now all these questions are based on element even or odd, then index even all and odd also. If whether you generate it directly the even and odd according to the question as indexes, or you generate every index and you check a condition, it's up to you. But which is better? I already gave the reasoning for that. Okay. So I want you to practice all these programs. Clear?
Clear, sir.
So next